The yearbook staff at Bayside High School is in the process of mounting photographs from the homecoming activities for the yearbook. They are to be mounted on 8.5 by 11 pages. The space between the photograph and the edge of the paper is X inches on all sides. Draw a sketch of the page, set up, and label the dimensions of the area covered by the photograph. So it says it's 8.5 by 11. So we got 8.5 inches over here for our width and 11 here. It tells us the space between the photograph and the edge of the paper is X inches. So that's this little section here. It's going to be X inches all the way around. X inches. And X inches. Okay, so knowing that, we can also determine the length of this section right here. Since this is X and this is X, that's going to be 2X. Okay, so we don't need that part in the length. Okay, so since the total is 11, we're going to subtract out the two borders. So 11 minus 2X is going to be our length of our photograph. Okay, same thing with the width. It's 8.5 inches. Subtract the two widths. So this is going to be, let's just write it like this, 8.5 minus 2x. So it's 8.5 inches total. Subtract 1x and another x, that's 2 x's. Okay, express the area of the photograph as a function of border width. Well, we want the area of the photograph basically, and the photograph is this section right in here, this rectangle right here. So we already have the length. The length is 11 minus 2x, and then our width of our photograph is going to be 8.5 minus 2x. So this function here is the area of the photograph in terms of x. It says graph and draw the sketch. So we're going to need a calculator here. So let me go get mine. Okay, so I went ahead and I plugged in our length of our picture and our width of our picture in terms of x into y equals. Then I went into window, and since x represents the border width, okay, so I knew that the border couldn't be less than 0, so I started off with 0. And then the border, that's the section right here, okay, I went ahead and I knew that if it's 11 inches all the way across, that if I made the border with 5 and 5, that would take up 10 inches of the 11, leaving an inch in the middle. That'd be a pretty skinny picture. So I just went ahead with 5 as my border width, and I decided to use a scale of 1. So I'm counting by ones. And then let's see, y minimum. This is going to deal with the area of this. So I know that it's going to have an area, so I'm still going to choose 0. That would mean that there would be no picture in the middle. This whole thing would be a border, which is not realistic. And then I figured, you know, let's say it's 10 by 10. Well, that's not even going to work because it's 8.5 here. So, but if it was a square, 9 by 9, maybe that's still too big. 8 by 8. This could be actually, I guess, 10, and this could be 8. 10 by 8, which would be 80. So I just went a little bit bigger, just to make sure that I had an area that's big enough. And then I went ahead and counted by 20s here. All right, 20s, 5s, 10s, whatever. I decided to go with 20s. So let's see what this looks like. All right. So it's going to start up here, and it's going to go down here like this. So let's plug this stuff in. My window that I chose. Okay. It says if the border width is 3 inches, what is the area of the photograph? So now all we have to do is plug it in. Although, you know, you can plug the 3 in for X, because X represents your border width, which is right here. Your X is your border width. So we could plug 3 in and find out what the area is. But why not, since we're using our calculator, let's go into our table and let's go to a border width of 3. So at a border width of 3, we have 12.5 square inches. Okay. We want an area of 56. So what should the border width be again? Remember, since here we were given the X value, okay, and it's a nice integer, you know, we can just find it here. We could have also done a second trace and done the first one, and we want 3, and then it'll tell you the area right here, 12.5. Well, going the other direction, now we've done this before, but we're given the area, which is a Y value. So we're going to go into Y equals, okay, we're going to plug in the 56 inches, square inches, excuse me, and then we'll do second trace, and we're looking for where it intersects. So I'm going to move my cursor near the intersection point. It doesn't have to be right on top. And you press enter 3 times. Alright, so our border length needs to be 1 point, and I'm going to go ahead and round it to 10th. So 1.1 inches, approximately. So approximately 1.1 inches. Okay, other side. So a gardener wants to build a walk of uniform, which means uniform means the same with X around his rectangular garden on all 4 sides. The garden is 16 feet long and 12 feet wide. So here's your garden, 16 feet long, so 12 by 16. We're building a sidewalk of a uniform width of X. So here we are again with that X all the way around. Uniform, meaning the same. So the same width all the way around. So, since this is 12, this is going to be 12. We've got to add the 2 x's. So 12 plus 2x. Okay. And then over here it's 16. We've got to add the 2 x's to get this length or width, however you want to look at it. Okay. It says express the area of the garden and the walk as a function of border width. So we're going to be using these two because these include the garden and the walk. So area is length times width, or width times length, as long as you're multiplying them together. Okay. Here we go, setting up a window. Always seems to be the hardest part. Let's go ahead and I want to pause it and put this in the calculator. Okay, so got to set up a window for this. So X is going to be your border. So we'll start at 0 again. And I think that 16 and then 2 more. You know, I'm just going to guess. We're not dealing with too big of numbers here. So this width could be 12 maybe, to leave some room for a garden in the middle. Well, let's see what it gives us. 12, count by ones. Okay, the area, we'll go with 0 again. Let's see. 16 times 12 is, it's going to be more than that. It's going to be more than that because we don't know what the border is. So let's say maybe 20 by 18, 378. We'll give it a try. See what we get. I'm going to go ahead and count by tens. Okay. So, you know what? I think I want to go a little bit higher on this area. I want to see it a little bit higher up. And I don't think I need as much over here, but let's go ahead and raise it up a lot. Let's go up to 1,000. I just want to see what this is going to look like. Now that looks good. So sometimes you just got to play with the windows until it kind of makes a nice picture. So we went from 0 to 12 on border width. We went from 0 to 1,000. Oops, on area. And it ended up looking like that. Okay. If the walk had a width of 4 feet, how many square feet of space would the garden take up? So again, we're given the width. So second trace value 4. So 480 square feet right there. We could have also gone in here, since it's a nice integer, and went to 4, and there's 480 right there. All right, if the gardener only had 350 square feet to use for the garden and walk, what size should he make the walk? Well, again, we're given the area, which represents the y value. So we're going to go ahead and go to y equals. We're going to put the 350 in, and we're going to find that intersection, just like we did in the last problem. We're going to get close to it, and enter, enter, enter. So it looks like the walk needs to be 2.4 feet. Okay, we'll see you guys tomorrow.